Hello, everybody. Just a quick introduction here. I'm Kevin Stewart. As mentioned, the project manager with EllisDon. Sort of a special opportunity here for me because I was part of this project here for the last 3 years, able to sort of see everything from pre-demolition to the completed building we're standing in here today. So this is a great opportunity for me to talk about this technology and how it was used in our project, and looking forward to sort of filling you guys in on that.
Yeah, thank you for having me. I think Kevin pretty much said what needed to be said. We've got some cool stuff to show you, and maybe we can hand over the model to you and you'll have some digital assets afterwards. Take it.
Perfect. So we're here. We know the building. Just wanted to touch on a couple things to bring some background to the project, so everybody had an understanding of a little bit of who was involved and that kind of thing. So we're downtown, as mentioned a couple times. I think this is the second building downtown for Fanshawe, transforming the old department store. It's the home of travel and tourism, culinary arts, information technology. I bring that up to specifically talk about culinary arts and the use of BIM here. We have a heavily serviced building. We have, I think I've heard the equivalent of about 80 different restaurants in terms of equipment, the amount of equipment in this building. And obviously that equipment needs to be serviced, gas lines, exhaust piping, exhaust ductwork, I should say. And that is really, one of the main uses of BIM that we were able to take advantage of on this building for coordination purposes. Just quick introduction on some of the consultants and contractors involved. Diamond Schmidt was the lead architect, working with Phil Agar, local architect here in London. H&A, our structural, Smith & Anderson, mechanical, electrical. On the contractor side, we were first retained as the construction manager. Smith & Anderson Mechanical bring on M&G Steel. We use their model for a lot of our coordination. Modern Niagara and Culleton work together for most of the M&E services to do the modeling and for all the final M&E. Just to talk a little bit more about the building, you're only able to see a small portion of it. I'll mention just quickly, I know someone was running through some of the salvaged items, Steve was earlier. Right above us, all these joists here that are the ceiling feature, those are all structure from the 4th floor that were taken out carefully, refurbished and brought back in just as a feature too. So that's just one more thing we've got in this building from the old department store. So just running through again, we got cooking labs and prep kitchens here. Most of that is where we have some heavy services, and we've got some great fly-through of the model that are going to show that. Classrooms and computer labs all throughout for the IT programs and for general learning. The demonstration theater as well, sort of a cooking show type of setup upstairs on level 2. The chef's table, restaurant and deli, school store, amphitheater, which we're sitting in now. Golf simulator room down the corner, which we have yet to try out ourselves here, but unfortunately. Yeah, and since this is I believe for most of the people in the programs here, this is their campus. This is they're not running back and forth to downtown. So this is their space. So they've got lounge space, locker space. This space here is normally filled up with 50 students just sort of sitting there, charging their phones and talking. So wanted to talk a little bit about the schedule. Again, it was a challenging project, and I think some of the background helps understand what we went through here for 3 years. We started working with the design team in June of 2015. At that point, concepts were already in place. Basically the design was set. So we immediately got involved in tendering some of the initial work. We had a lot of abatement to do in this building. It's an old, chopped up building. The demolition obviously came next. We started, all of the building was down with the exception of the facade, which we had to actually retain by June of 2016. And then we were up and out of the ground with steel in the fall, actually tower crane up in October. So talking a little bit about how that relates to the BIM scope. So we did have a design model, the architect and the M&E contractors, I'm not sure if structural was involved, used that for some of the initial coordination, again, for the heavy M&E services in the building. Phase tendering, I mentioned that because, and some people have alluded to, how how much adoption, I think Gary was saying how much adoption we had of BIM on a full project scale. We were only limited to what we could do. So structural steel was using it, but had pretty much developed their model before really our mechanical and electrical contractors were brought on board or were up to a point where they could work. So I mean, we had sort of two different phases of modeling. Of course, we were able to work through clash detection with them, but being that it's a phase job, there's some challenges that way of sort of coordinating those services together. And of course, once the building was down, we were able to use our 3D scanning technology to just assess what's here. We had the demolition here involved, even before we took the building down, shoring up of the east and west walls, which are shared with our neighbors. And some of that we tried to keep within the neighboring properties, but obviously there was some shoring, and we've got some great snapshots of that as well. And what we used that for, we tried as best we could before the building came down to lay these shoring structures out so that they were going to miss the structural steel in the building. And we used the 3D scan and the steel model as a final check for that as well. So I mentioned the shoring phase here. So this is a photo looking north with the building sort of more than half down for sure. So these are some of the shoring posts that were put in to hold up the neighboring properties. And we were able to, again here, as we said, use the 3D model, this 3D scan to compare that to the to the steel model there.
So in this video, we're actually looking south and we're traveling backwards along this very wall right here. So you can see in gray, that's the point cloud. And then obviously the colorful stuff is the steel model. And every now and then you'll see shoring appear. And you can see how it interacts with the future steel. And this is obviously the heritage facade out front and how that interacted with the future steel as well.
Yeah, so there's some final checks there as well, tying into that with a new structure. We were able to take the steel model and just give that to, or the 3D scan, and give it to the steel contractors for just some last minute dimensional checks with the existing conditions.
This here, obviously more of the point cloud versus the steel. It's when you see the rotation on the left-hand side, you'll see every time it hits a floor, it's actually, it goes a little bit white. That's what level it's at. And those other two views are different views of the point cloud section as it goes through, kind of like a CAT scan. So this is going from top to bottom, and then we're going to switch and we're going to go from south to north.
And you can see we did the scan, not even interrupting construction. You'll see kind of some of the outlines of excavators, and we had a caisson drill rig here as well the day we did the scan. So everything was kind of moving along tickety-boo while this was all going on. So
luckily, all our scanning personnel survived. Oh.
Okay, so just a couple quick snapshots of examples how we used, and there wasn't a lot of issues to check on, but the challenge of coming to the site and having to find a plan B to erect the steel if one of the main members happened to interfere. Again, we were confident that wasn't going to be the case because we did take some time to lay it out, albeit more by hand than it was through a modeling program, but this was our final check at that. So just a couple examples of, we'll call close calls. I think there was one scenario over on this side of the building that we were within an inch of the existing shoring with the new steel, but everything worked out just fine. This is on the southwest end of the building, just in the restaurant there. So just another example of where we had to plan out the locations of all these shoring posts around the existing steel. So we're just going to talk a little bit more about versus the structural aspect here. Omar is going to talk a little bit more about the model and how it was used for the M&E services and clash detection, that kind of thing.
So Kevin, how many restaurants did you say?
80.
The equivalent?
80.
The equivalent of 80 restaurants in one building. So it just boggles the mind, from my experience, the amount of mechanical, electrical, and plumbing that is needed to support that much You've got the fume hoods, you've got the drain points, you've got obviously the gas lines and everything else, fire sprinkler systems. So all of that, equivalent for 80 separate restaurants, needs to be shoved into one building. So that's just to prepare you for what had to be dealt with when it came to coordination. This is actually the mechanical penthouse. You can see, and this is the trades model, right?
Yep.
Who was the trade?
Modern Niagara.
So Modern Niagara. And obviously they had to do a lot of coordination. Generally when we start 3D modeling and coordination, we want to follow the construction schedule, which means bottom up. We tend not to build a building from the top down. It's kind of difficult with gravity and everything. But that being said, you obviously want to also take into account the complexities involved with that, i.e. when once you get to the mechanical penthouse, obviously it's one of the most complex mechanical setups in the building, so you kind of want to give that a bit of a head start. When you're going up the building, let's say each floor will take 4 weeks, but the mechanical penthouse will take 8. So as soon as possible, you wanna try and do a pincer attack and do multiple floors in order to be able to ready when it's time to install the sleeving or start prefabrication of mechanical, electrical, and plumbing materials.
So really what that was used for was being able to take this model well before the steel was even up, and for all of the larger size piping you see in there that connects all the major pieces of equipment, that was all spooled up and built in their shop. So they came out with a few truckloads worth of mechanical piping, brought it up just before we closed up the roof, dropped it into the penthouse, and from there it was just sort of putting it together like Lego. So saves a lot of time on schedule, saves a lot of time on, oh shoot, this doesn't fit the way we thought it was in the mechanical room. It was a very packed space. I wish we could tour through there and after, but I don't know if they're gonna let us do that. But that was a great use of the technology for sure.
Here we're going through the building. These are the 3rd and 4th floors. Kevin and I specifically picked this to go from the back to the front of the building in order to show you what's happening in between these floors. So Kevin, what's on the 3rd floor?
The 3rd floor is mainly the cooking lab. We're going through one of the savory labs right now with a central hood. This is the both the exhaust and the return air, makeup air here.
These are obviously drain points for the mixology room above.
That's right, yeah. And now we're into one of the last savory labs on the north end of the building, and this is more of an island-based setup for the cooking station, so it has a lot more distribution in that room for sure. There's 2 of those.
You can see the density of the ductwork there. Additionally, while you might, before the ductwork goes up, you look up and say, oh yeah, there's plenty of space. But you have to remember that ductwork tends to go straight, and it tends to want to go past the steel. And the steel takes up half the space. So while you may see 2 feet of space, you've actually only got 1. Because if the ductwork goes up and down, that builds in resistance to the airflow, which in turn requires that you need a bigger air handling unit, which means you need to upgrade the structure in order to handle the weight, and it just ends up cycling and snowballing from there.
Yeah, so one last fly through. We like the last classroom that we got into here just because it's such a maze of ductwork mainly, but there's some piping in there as well that was all coordinated with it. So just a great taste of what we don't see below the ceiling, obviously.
So this is our final video. This is the tree dimension. So this is Diamond Schmidt's architectural model, and we're actually going to be flying in, and we're actually the viewpoint is going to shift to the right a little bit, go through the turnstiles, fly through this room, and then go back out through the corridor. And the interesting thing is, so since the scan was taken while there was active construction happening and the excavation wasn't fully complete, you'll actually see point cloud machines sitting in the finished space. So on the left-hand side, you've got a little bit of the top of a bit of a machine. Here you're entering through the turnstiles. Show of hands, how often do they work or not work?
Don't ask.
There we go. So right up there in that space where the food spread is, you've got a dump truck currently in full release. And as we travel through the glass, you'll actually be able to see down into this space, you'll actually see a surface. So when this point cloud was taken, the excavation wasn't complete. So you're actually going to see dirt or point cloud representation of said dirt. And that's actually a tripod setup right there, probably with a total station for surveying. And here we're walking over the top of it's a digger. I call it a digger. What is it? It's a digger?
That's what my kid calls it. It's an excavator.
It's
sure.
an excavator.
Yeah.
There we go. The technical term.
Yeah.
Clearly, I've been reading too many "If I Was a Digger" books to my 4-year-old. And of course, there was this lovely blue crane base was where the crane was while the building was being constructed. It's another thing that tends to be overlooked when you think about BIM, but also the temporary equipments. And here you've got different angles depending on when the scan was taken of the caisson. Was it caisson or?
Yeah, a drill rig. Yeah.
Drill rig.
Yeah.
But back to my point, you don't really think about all the temporary structures such as a crane base. So we don't have an image of the whole model. We decided to omit it from the presentation, but there was a nice big yellow concrete block underneath the building, which is the crane base, which is the actual block for the crane base. And we had to figure out where to put that block, how to pour that block, and then backfill over that block, as well as if the crane is there while we're building the building, obviously, what does it impact? What are we going to have to delay with regards to installation until after the crane has been taken out of the way? Lots of fun logistics stuff like that.
Thank you.
Thank you.